I'm Rajesh Uppal, founder of IDST. We bring you sharp insights and foresight on emerging tech, defense, and security. Let's dive in.
When you think about electronics, your mind probably goes straight to microchips, sensors, and processors. But here's the thing, none of those would even work without something equally critical, yet often overlooked: electronic packaging. This isn't just about putting gadgets in a box. It's about creating highly engineered enclosures that protect delicate components from heat, shock, moisture, and electromagnetic interference, while making sure they can still run at peak performance. And in today's world, where devices are getting smaller, faster, and more complex, packaging technology has become a high-stakes game in both civilian industries and defense systems. Decades ago, packaging was basically just a shell, a metal or plastic cover to keep dust out. Now, we are talking about multi-layered systems made from advanced ceramics, composite materials, and even nanomaterials. These aren't just strong and lightweight, they're thermally efficient, chemie-resistant, and built for extreme environments. In the civilian world, that means sleeker, more powerful smartphones, compact medical devices, and wearables that can survive daily abuse. In the military world, it means electronics that can operate flawlessly in deserts, freezing mountain ranges, or even deep space, without a hint of failure. The packaging industry works in levels. At the most basic, you are protecting a bare semiconductor chip, a fragile speck of silicon that can be destroyed by the tiniest static discharge. Move up the levels, and you are packaging entire circuit boards, modules, and finally, full systems, each stage adding its own layer of shielding, cooling, and structural support. For a consumer product like a laptop, packaging might be optimized for style, portability, and low cost. For a fighter jet's avionics system, the packaging might need hermetic sealing, shock absorption, and radiation hardening, tested under conditions that mimic supersonic flight and missile launches. And the material science behind it. It's fascinating. Metal enclosures still dominate in high-performance and military systems, offering unmatched shielding and durability. Plastics, particularly molded polymers, keep consumer devices light, cheap, and easy to produce. Advanced techniques like potting, vacuum encapsulation, and conformal coating make sure components are sealed against moisture, dust, and even chemical attacks. In space applications, ceramic and composite packages are often the heroes, keeping electronics safe from radiation and extreme temperature swings. Manufacturing has also leveled up. Injection molding allows for millions of precise, identical parts at lightning speed. CNC machining delivers precision for low-volume, high-value equipment. And 3D printing. That's opening up design freedom like never before, letting engineers produce complex, lightweight shapes for both commercial drones and military surveillance systems. Of course, it's not all smooth sailing. As devices get smaller, heat dissipation becomes a massive challenge. Add in the need for eco-friendly materials, compliance with environmental laws, and the push for longer lifespans in mission-critical systems, and you've got a design puzzle that never stops changing. But innovation is keeping pace. We are now seeing wafer-level packaging, microfluidic cooling channels inside enclosures, and even biodegradable anti-static films that protect electronics during shipping, like EcoCortex compostable packaging, already replacing hundreds of kilograms of plastic waste each month. The future of electronic packaging is about convergence, smarter materials, greener processes, and designs that aren't just passive protection but active partners in performance. Imagine military radios with self-healing casings after impact, or civilian satellites with real-time thermal monitoring built right into their shells. Whether it's for your next smartphone or the electronics that guide a hypersonic vehicle, packaging is no longer just the box, it's part of the tech itself. And as we push into an increasingly digital, connected, and high-performance future, the box might just be as important as what's inside.